Good evening, Mr. Ramirez, our awesome TAs, to include Rockin' Ricardo and Solomane, and of course, our cool cat classmates. My name is Rob Clapp, and it is my distinct pleasure to present our Team PupBot final project to you. Tonight, we will be presenting our project description, project design, code review, summary of our work, a demonstration of our PupBot creation, and we'll conclude with our final thoughts regarding this fast-paced course. Team PupBot is comprised of Andrew Pham, Chris Crane, James Sun, and myself. Our goals entering this project a long 7 weeks ago was to have a PupBot react to our faces after finding that many of our robot cameras were just not designed to look up at faces. Our goals were modified slightly to include object detection, avoidance, following, and retreat. While the first 3 goals were met and perfected fairly quickly, retreat from objects proved to be a bit more challenging, and I'll discuss this more in future slides. A pseudo goal of this project was to reach full level 5 pet autonomy, but at this point, as you can see, our PupBots are out of gas, and this picture brings a whole new meaning to autonomous PupBots crashing. Team PupBot is all worn out and wants to know where we can apply for robot frequent driver miles. Our resources used for this course encompassed our Jupyter Lab environments, our GitHub repository, Slack, Google Meet, and Google Drive. I will break away from this presentation temporarily just to show our resources. First of all, one of our major resources is Slack. This is where all team members share documents, provide comments, and coordinate activities. We also have our Google Drive. This is a quick look at our final project, public artifacts. These artifacts will be linked, and you will find those links on our final project report. We have our Team PupBot GitHub repository, where we all post our different code. And finally, we have our Team PupBot code review and our Jupyter environment. I will come back to this once we discuss code review. All right, a little bit about our robots. As you can see from this hardware list, we all, of course, have the Jetson Nano Developer Kit board. We have our WaveShare JetBot AI kit. We had one person with that. I believe that was Andrew. Chris had his SparkFun JetBot. And me and James rocked our Yaboom robot-like, tank-like JetBots. Really like those. They're really cool. Okay, so let's take a look at our robot mugshots. Here's our mugshots with Chris having a lot of Spark summer fun, James and I, you booming the days away, and Andrew catching a few waves on his WaveShare robot. I wish we could say this semester was that relaxing, but not quite. Take a little bit of a look of our project design. This is our initial PupBot design real quick. You can see it shows video feed input. We learned along the way that it's more like camera shot input. Here's our original use case based on our face detection. And as we mentioned, when we found out that face detection wasn't easily obtained with the face and the people, we adjusted our use case based on object detection as shown here. All right. Our primary code development environment for this project consisted of our Jupyter Lab environment and our Team GitHub repository. We've already shown you that. This is simply a listing of our third-party libraries and data sets that we used to develop our robot code. These are modules and some modifications to the code that we needed to make to ensure that our PupBots behaved properly. And now I'm going to break away from this presentation once again to show you our code and compare our versions to identify how we could get that elusive robot retreat to finally work for us. Okay, as you can see here, this is our team PupBot. This is where we have our different versioning of our code. The only place that we have all the dependent modules and everything is in our code version 3. That's our most current version. But we're going to take a look and we're going to open up the revisions of this code just to give you a look at what we did. And let's go to version 3, PupBot v3. Okay, so in our initial iteration, we had our team members listed. Our objectives were still not nailed down because we were dealing with our facial recognition and we're going to go with object detection. We finally decided to go with object detection. Of course, here as well in our code snippets, we had our project code first, followed by our data collection code and our model training code. Looking at this, we decided that, hey, maybe we should go into a different way of doing this and maybe have data collection first, model training second, and then finally break into our project code right here. So we decided to do that. So in version 2, simply we had our project objectives identified through the team. We were able to finally list those. We did our data collection first. We did our model training second, making sure that we understood that we needed to do a kernel reboot. Most likely, for a lot of us, that was the case. And finally, needing to do an entire robot reboot for our project code because it would not release the camera from when it was captured up here in the data collection module. So, as you can see, this entire structure can allow us as team members on any of our robots to go through this iterative process of data collection, training our model, and finally implementing our project code. So, sounds easy enough, right? Well, what we found was that we were having a difficult time trying to get our robot to turn and run. And we wanted to have that retreat functionality. So coming down to this project code, it's quite a bunch of library imports. We're going to call on our different modules here, different plugins. And what we're really looking at is this right here, because in our initial part of our code, we didn't have that in the beginning. And thank heavens for Chris, he was able to detect that and was able to resolve it. And I want to show you a little bit of what we did. So do this, open that one, then bring this one full screen, and we can see that on the right, you see that we did not have an import of random as the RND variable here, but we ended up adding that. More importantly, we needed to add a little bit more code here. And we were able to add those to turn the robot 90 degrees here so that we can get it to get away. And also we added this block of code. Okay, so we're going to scroll down and see that we needed to add another 3 blocks of code, which is identified here for calculating distance to detection, determining if that robot is too close to the detected object, and finally the running away portion of our code. So that was really, really good. To a lot of our wicked smart fellow classmates, I know that might have come easy for you. For me, with my old hard-headed self, it took me a little while to get there. So that is a little bit of our code review to show you our different versionings of code. And now we're going to proceed to our project work. As you can see, don't look at this too long. It might give you a headache or put you in a trance. It's kind of crazy looking colors. Let's talk a little bit about our team contributions. First of all, Chris was first on the team to complete full construction of his SparkFun robot. He was also the first to complete a lot of our tutorials. And he also, wicked smart guy, has been doing software engineering for over 20 years. And man, we really needed him. He reviewed and provided input into our initial project proposal, of course, as we all did. He definitely led the way in architectural design and developed a majority of our code. He committed the first Jupyter Notebook code for us, and also added the different modules and everything that we needed to make it work. He updated code to GitHub repository to provide added functionality, and of course, he played a huge part in continuously refining and improving the code during code review. Next, James' son, my man James, he reviewed the initial project proposal. Really hats off to him. He took the time to get with our TA, Rockin' Ricardo, to ensure that our project scope was properly defined. And of course, you might know him as our PR person. He really was the face of the team. He recorded a lot of our video updates. So whenever we were called on and put on the spot by Mr. Ramirez, I always had his videos in the back pocket. Knowing how hard he worked on those, I was glad to show him off. Really good guy. Committed, of course, data to the GitHub repository, customized our code, and committed a lot of code during code review and Q&A. All right, then we got Andrew. Of course, he reviewed our initial project proposal. He was actively involved in all phases of our project completion. Of course, committed a bunch of data to GitHub repository, customized tons of code, initially posted by Chris to ensure operability on our various different robot platforms. And addition to committing code, really great recruiter. I think that Andrew and I were the initial team members for PupBot, and we were able to go out and get James and Chris, and really good job to Andrew on all that he's done. Finally, me, I didn't do anything but lay on the beach. No, seriously, formatted a lot of the team documents for team review, comment, modification, finalization, provided as many inputs as I could into team projects, presented our updates to the teaching staff whenever our awesome instructor would put us on the spot, and I learned how to tap dance very well. Updated code, collected a bunch of attachments and stuff for developing our final project report and our presentation, committed and modified a lot of code to the GitHub repository, and you know the drill. Committed updated camera data to improve detection following avoidance and retreat to the GitHub repository. So, okay, now it's our demonstration portion of our presentation. As you're going to see in just a few minutes, these PupBots are crazy. All right, here is our demo of our robot. This is in Chris's living room. Robot's running around, as you can see. It's got the object detection. It is letting you know the different couches, the different things inside of the house as it's driving around. Of course, it is using object avoidance to ensure that it doesn't run into anything. So this is kind of cool. And again, you can see it's still detecting with the blue boxes around different objects. And you saw Chris, it didn't detect Chris there for a minute, and then there's his wife, he's coming, oops, sees a foot, I gotta run. So there's our retreat function that we were working to try to obtain. So now it's still going around, still doing its object avoidance and its object detection. And there's Chris still hanging out. It still doesn't see him sitting there on the chair. Still driving around, always ensuring that it doesn't run into anything. Up, now here it comes. Someone's walking towards the robot. The robot turns. And it's still running around in circles, avoiding objects. Oh, there's Chris. Now it's going to detect. Watch. All right, it detects a person. Guess what it's going to do? It's going to turn and retreat. That's an awesome function. I was mentioning that earlier. It took us a long time to figure that one out. Well, probably me a lot longer than it did for Chris. So, and then it detects a person once again. It notices that it's getting close. Oops, it's going to turn around and it's going to totally retreat the other way. So, it's pretty cool. And we've just got this bad boy that's running all over the house. Again, detects a person once more. And if it's going to be true to what, oh, it turns before it even gets close. So that's pretty much it, folks. That's our demo. And we thank you very much for this opportunity to show you this. So what did we talk about? Again, talked about all these topics. One more time. Just to refresh your memory. And in conclusion, all I can say, this was a wicked, fast-paced summer course. I feel like we were all drinking robotics concepts through a high-pressure fire hose. I guarantee you we could rule the autonomous world if only we had all of Tesla's data. We can all see that the future is very bright for artificial intelligence, machine learning, and autonomous vehicles. Finally, Mr. Ramirez, Ricardo, and Solomon, a sincere thank you from our team. We appreciate all that you did for us throughout the semester to help us understand the concepts that were just, like I said, thrown at us at what seemed to be 90 miles a minute. You guys have always been there to help us out. We certainly appreciate all the support and the interaction that you provided throughout this semester. So just want to say to all of you, have a great summer. Our classmates, you guys, I know you're doing awesome for these final project presentations. I wish you all nothing but the very best for your future, both in your education and your life. God bless you guys. And with that, I'm just going to say, do we have any questions?